This is episode number 29 of DevOps Paradox with Darin Pope and Viktor Farcic. I am Darin.
I'm Viktor.
And in yet an ongoing series of guest episodes, we have a new friend with us today. Viktor, why don't you introduce Philipp?
Yeah, I'm not sure how to characterize the relationship. So probably the closest description would be that Philipp is a conference buddy. We meet each other in random conferences in random places around the world. That's how we know each other. And Philipp, you can introduce yourself, but in short version is that Philipp works for Elastic. He's developer advocate or something similar to that. Anyway, he works in a cool company. He's a cool guy, so he's in.
Hi guys, thanks. I'm always kind of like careful to say work because I have the feeling I travel most of the time. So as a developer advocate, I mostly go to conferences, meetups, and just around to spread the love for the stuff that we do. That's pretty much my work, and that's how I run quite frequently into you, Viktor, because I'm sure you're working. It's just me that is mostly traveling.
Yeah, something like that.
See, we talked about this last time. You DevRel guys, you just get on a plane, go to a conference, have dinners, get to play. Me, not so much. I get on a plane, I live in a hotel for 2 weeks, going back and forth to clients. But that's okay, I enjoy it.
But it's not that different. The major difference is that we speak with more people than you at the time.
Yes.
And then now here's the important difference is that people usually come to speak to us because they want to. And very often people come to speak to you because they're both.
They don't have a choice. Yes.
They don't have a choice.
Yeah. I usually get to go deeper with people than you guys do.
Yes, that's
right.
True.
So it's trade-offs, and that's the part of me being an old guy and trying to think I have wisdom to share with people. That works out pretty good. But anyway, all right. So I've already digressed, and we're only 4 minutes in. Not even 4 minutes in. So you work for Elastic.
I do.
Okay. Are you stretchy today? No.
Stretchy? No. No, I've been with Elastic for 3.5 years, which it was kind of a smaller or much smaller company back in the days. And we've kind of grown up quite a bit since then, with all the good and the bad parts, I guess, because larger companies have different opportunities, but also slightly different problems sometimes. But yeah, that's where we've been going at for a while. And I've always kind of been a developer advocate, though I've been in various teams at Elastic. So I've been part of infrastructure because that's a bit of my background. And then our team was moved into product, and then product was dissolved, and we're part of engineering. And right now I ended up in marketing, but it has always been the same role. I've just been bumping around. And my takeaway of that is that, especially with any startup-like company, the only constant is change. Like, stuff will always change, and then you need to make the most or best out of that. And for me, that's mostly going out to the community and showing the stuff that we have, but also bringing feedback back. And I'm not doing consulting, so it's very much best effort and shorter, but I do try to solve a lot of problems that people have, either at events directly or Stack Overflow. We have our own Discuss, etc. So we try to not do proper consulting, but at least help people. And my job description, I think, is always successful users. So it's not necessarily paying customers. It's really successful users. It's either I show you stuff that you could do with our stack, or I try to solve your problems, just that you're successful. And maybe later on you will become a paying customer. But that's somebody else's problem, quotation marks, kind of. So I just try to make people happy and successful, and that's why I'm here. And I think that's a very nice job. And luckily, if you have a decent product, your life is much easier.
Okay, just in case people are listening and do not know who Elastic is what their product set is.
Stop.
What?
Show me a person who never heard about Elastic. Come on.
I can name off a few that wouldn't know Elastic, the company, but know their products.
Yeah, that's probably true. So Elastic actually started off as Elasticsearch, the company, but then more and more products joined the family. We always say they joined the family. So initially it was Elasticsearch, the Datastore, and then we added Logstash to parse and ingest logs, and then Kibana for visualizing. And we keep adding things over time. So we added APM, and then there was a cloud company that joined, and now we have everything as a service. And we are doing more and more in the security space. We recently acquired a company about endpoint security. So security is getting bigger, and we're pretty much all over the place nowadays. But one thing, since most people will know Elasticsearch, for us, everything is still a search problem. For example, logs, but also security events or tracing. The storing part is normally the boring part. Nobody wants that. What is kind of relevant is finding the relevant stuff in that data. And that's why for us, where we're coming from is like the full text search space. But for us, all these other problems are still kind of search problems, because only if you have performance search that will also scale, you will be able to take all of that data and then get some value out of that. So that's basically the philosophy of Elastic as a company and our products then. And we add more and more use cases and solutions around that. But if you've never heard about Elasticsearch, if you're searching on Wikipedia, Stack Overflow, GitHub, behind that little search box, there is always Elasticsearch doing the search. And then there are various other companies using it for logs or metrics or tracing or security events and many, many other things, because it's kind of like a bit more like a platform, and then you can build a lot of things on top of it.
And again, for the uninitiated, Elasticsearch is a search engine. But if you've been in the Java space at all, what are the I know most of them, but what are the components that make up Elasticsearch?
Yeah, so that's actually a good point, because sometimes people are very confused. They're like, what is actually storing the data in Elasticsearch? Are you using MySQL? I once had somebody from Oracle, I think, and they were assuming that we were using MySQL in the background, because I don't know, everybody does, but that is not true. So the search library that is actually storing the data on disk and doing the kind of heavy lifting around search is Apache Lucene. And we have a couple of folks working full-time on Apache Lucene to move that forward, amongst like others are also contributing quite a bit there. But we do invest heavily into that. And then Elasticsearch is kind of sitting on top of that. So the thing that is actually doing the search part and writing to disk is Lucene, and then we have Elasticsearch around it, which provides a REST API, the query DSL, it distributes and replicates your data. That's kind of the Elasticsearch part. That makes up the probably most widely used search engine you have out there.
Now, isn't Solar in the mix in that too?
Well, Solar is also based on Lucene, but Solar is kind of I don't want really to say competing, but it's kind of like an alternative search implementation. So Elasticsearch and Solar are kind of on the same level, more or less. And then Lucene is the common thing they're both built on. But Solar has kind of come more from the powerful search side, and Elasticsearch has more come from the distribution side. So Solar also has something called Solar Cloud to distribute it, but that needs another component then and makes scaling a bit harder, whereas Elasticsearch has always come more from the scaling side as a first-class citizen, and then added more and more search features, but also other use cases on top of that. And whereas Solar is generally very search use case focused, Elasticsearch has kind of evolved from search, which we still do because everything is a search problem, but also to logs and metrics and security tracing, all these other use cases. Whereas Solar is mostly focused, I would say, on the full text search part. Also because we have Kibana, and I think Solar had some clone of that was called Banana, but that didn't go anywhere. But I think it took the code of Kibana and then tried to put that on top of Solar. But I think you can still find it on GitHub, and I find the name hilarious, but it didn't really go anywhere. And Kibana is definitely one of the things that many people, especially if you're more on the management or data management side or whatever, many people don't know that they're using Elasticsearch. They're saying like, oh yeah, I know Kibana, like we're using Kibana. Elasticsearch, I've never heard of that. But it's kind of implicitly there because Kibana is always using Elasticsearch then for storing the data.
Yeah, because Kibana cannot be standalone ever. I mean, it's dependent on Elasticsearch, right? Yeah.
Yes,
so
I'm kind of careful saying it's stateless or anything, but it's more the front end that doesn't keep any persistent data. Like even its own configuration ends up in Elasticsearch again.
Right. No, it's completely safe. It's fine to say stateless. Of course, we haven't started fighting yet. What kind of things can we fight about here? No, okay. So this is showing my age. I used to write stuff straight against Lucene before Elasticsearch even existed. And Lucene, man, that was game-changing for me for a lot of stuff. Now, it was smaller use cases, but it was great.
But kind of, to me, the whole story is so fascinating. Not with Lucene directly, but that until, I'm guessing now years, like, let's say 15 years ago, there were like 4 databases and they were all the same in general usage, kind of like, MS SQL, Oracle, and a few more. And I always thought that that's part of at that time, that was probably the only part of the industry that wasn't changing at all. Kind of like, what is there for next 50 years, that's what. And then suddenly, kind of the whole market exploded, kind of like within a few years, we don't even know how to call all those things that store data anymore. And then that whole evolution is really, really, it reminds me in a way on Kubernetes, not in terms of a purpose, but kind of there was that sudden explosion that in database space. I cannot give you the exact year now, but maybe 15 years ago, something like that.
Yeah, I think it was like the second half of the 2000s when you got Cassandra and MongoDB and Redis and everything popped up and everybody had a different use case. And it was the buzzword side of the NoSQL ecosystem, I guess. And right now we're kind of stabilizing again. And there is still more innovation, I think, and many more options than before, but it's not as crazy where there was a new data store. And you could basically tell when an application was started based on what backend they were using, because you could see like, oh, this year it was CouchDB, and then 2 years later, CouchDB was kind of out, and everybody started with MongoDB. And at some point, we realized that maybe the specific use case makes more sense than the fanciest data store of the year, but yeah, we're getting there. Or if you want to kind of like argue and discuss, what you can also always argue or discuss is Elasticsearch a database or not? And we're kind of very careful with that one because we're always trying to say like it's a data store. And it then depends very much on what you're trying to do, because we don't have something like multi-document transactions, for example. And there are some read anomalies, for example, that you might run into. And by now there is a read-only SQL interface, but it doesn't use SQL. So there are some things there that you would maybe expect from a database that we don't have. On the other hand, that makes us also very useful for other use cases because of the scale and the flexibility and the search capabilities.
So I'm getting confused now. What is the difference between database and data store? Until this moment, I thought it's the same thing.
Yeah, so I think that a lot of people have very specific associations when they think about database, that it's like transactional and you have a SQL interface to talk to it. And we don't fully fulfill those. So I don't want to say it's an excuse, but it's one of our ways to say, like, we would rather call ourselves a data store and not get into the discussion of like, how does this compare to everything else? Because we don't want to be MongoDB. MongoDB wants to be like the new database that replaces MySQL or Oracle or whatever. And I don't think that is really our core use case. We have a lot of use cases that we can take over from those, but we're not trying to be a full replacement. Like we don't have any plans that I would be aware of to have like multi-document transactions right now. And you might want to have those. I mean, MongoDB, for example, added those, though they're always saying like for most of the use cases, you don't really need them, so don't use them. And we're like, yeah, if you need transactions, we're the wrong solution. There are others.
That's interesting. You actually say that you can be the wrong solution at times.
Oh, yeah, totally. I mean, I find that kind of weird when somebody would say like we're always the right solution. Because since you're in consulting, I guess one of your most common answers is it depends, and afterwards it will cost a lot of money on what it depends on. But it definitely depends, or there are use cases where Elasticsearch is not the right solution. So if you need like transactional guarantees, like we don't have the transactions in that regard. Or for example, one way that Lucene writes the data, there is this, Lucene, the way it writes it creates the so-called segment once every second by default. And you cannot search data as long as the segment hasn't been created. So you might store some data, and it might take up to a second by default that the document is actually searchable again. And that is another attribute that people find very confusing from data stores or databases, actually, because in a database, you write something, you read it back immediately, which isn't necessarily the case for a full-text search engine like Elasticsearch. Well, I would be careful calling it a database because that's another attribute that a lot of people might expect. And we don't have that, or it's just handled a bit differently.
And the reason why it's handled differently is because of the GUI center, Lucene. That's not how Lucene works, so therefore...
Exactly, because that is the way Lucene structures the data. It's writing the data immutably, and then you create one of these segments once every second, but once it's created, it's always there. If you update a document, it would basically be marked as deleted and then written anew, and then would only be searchable in a new format once the new segment has been created. So it's just a different kind of data structure in the background that we're building on there.
Now, this is an interesting thing. The more that we've been talking, there are some interesting parallels from how Elasticsearch has been built and how Kubernetes was built. At the root of Elasticsearch is Lucene. Is that a fair statement?
That is definitely a fair statement, yes.
At the root of Kubernetes is Docker. Right? I could be completely wrong. I could be completely wrong. So
okay, let me state it. You are completely wrong.
Okay, good.
I think Viktor is hurting right now.
But do you see where I was trying to go with that? There's some interesting parallels that
I think that you could say that at the core. So it's a slight. I'm going to slightly modify what you said. At the core of Kubernetes are containers, or you could say LXD, for example, right?
Yes.
I mean, when I say containers in this context, I mean Linux containers and all the namespaces and stuff like that. And then Docker happens to be one of the implementations.
Right.
Yes. Container engine is at the core of Kubernetes, definitely.
So we're both of these larger, I don't mean this disparagingly, behemoths of software, all at their core are open source concepts, if not an actual open source project. Yes or no? I'm okay being wrong again too.
Yeah, I mean, at least in case of Kubernetes, the core is always open source, and then companies build on top of it their enterprise offering or whatever brings income one way or another. I mean, some companies not even get income from it, but yes, at the core is open source.
I mean, that is true for Lucene as well, because it's Apache Lucene, that's all Apache licensed, so that's an open source project. For Elasticsearch, it's maybe, I don't know, I don't want to say more difficult, but we have a multi-licensed approach. So we have a lot of stuff that is Apache 2 licensed and open source and has always been and will be there forever, or as long as we're around. And then we have a so-called basic license, which is a free tier, which has one of the limitations is you can use it as long as you want, and you for yourself, but you cannot sell it as a service to others. So kind of the idea is, if you want to provide a cloud service, or if you want to use a cloud service, that's fine. But we would like to be the ones that actually get the money and then funnel it back into development of Elasticsearch, and not others monetizing our work. That is basically that. And on top of that, we have another few components which are commercial. So you will need for production a commercial license. But that is a bit uncommon, is that all the code is source available. So even the commercial stuff is in our GitHub repository. Everybody can see what is going on there, which is actually very nice to figure out if you're running into any trouble. You can actually check out the code. What is actually happening here? What is the problem? And you can also follow all the issues, because before it was kind of complicated. If you have a closed source project, then the support team would say like, hey, yes, we've created the issue for you. I know you cannot see the status, but we'll let you know once this has been fixed. And this is no longer the case. Now you can just follow the GitHub issue because all the code is open. You might, for some features, need a commercial license. A lot of it is still open source, or you can use it for free. But everybody can see what is going on and has kind of the full visibility and can learn from it and can figure out what is actually happening. So you're not relying on support to tell you, yeah, this is supposed how it works. You can just check, what are we actually doing?
So that's really interesting. I didn't know that, to be honest, but sounds really awesome. Kind of transparency in a way, and following issues. I love it. But is there a fear that kind of, somebody will just take it? I know that kind of other companies I'm working in or work with, kind of they always kind of tend to separate it. You can see the source, you cannot see the source. We have 5% of competitive advantage nobody can see, right?
So I think the competitive advantages is there are many things in competitive advantages. Is a brand name, it's the code, it's also the knowledge about the product, because nobody else could support the product as well as we do, because, well, if our support doesn't know, they will go to the engineer who has actually written the piece of code. So I think that puts you on a different level. If that translates to direct sales is always a different thing. What I think you need to kind of keep in mind there, that open source is a great concept and we always call it kind of a force multiplier, and to get things out and to share and to show. But it doesn't put any limitations on that. And as a company, you also kind of like need to make sure you as a company survive. So it doesn't help anybody if you die. There were some other NoSQL data stores that kind of were too nice and open and didn't find a business model, and then they went out of business. That doesn't help anybody. Like RethinkDB, they were like the document store that everybody loved. Like everybody hated on MongoDB and everybody loved RethinkDB, but then RethinkDB didn't find a business model and they went away. And I think the source code is now in the Linux Foundation, but didn't go anywhere. And nobody is benefiting from that. And at the same time, you cannot complain that somebody takes your code and provides it as a service if it's open source, because that's kind of the point of open source. So I don't think it's fair to complain about that, but you can do something about that. And that's why we have these 3 different license level tier, basically. So there is open source that everybody can use and provide as a service any way they see fit. But there are also a lot of features that you can just use for free if you run it themselves. But as soon as you want to have the cloud service, we would like to be in the loop in that, please. To make sure that we can sustain the product and build a lasting thing there.
All right, so let's get away from the legal stuff for a minute, because my head's starting to spin. Or maybe it's the energy drink that I had. What has been one of the more interesting use cases you've seen that sort of made you think, I would have never thought to do that? Or has that never happened?
That is one of the interesting things about open source, is that people will just use your stuff for things you have never anticipated in good or bad like unexpected ways, and then it might break in a totally weird way. So that's something that you see every now and then. So I think initially it was very much like, yes, we're doing search. And then people started to use it more and more for logging, and then when we were like, oh yeah, this actually makes a lot of sense. So it's kind of this evolution of where you can go next. So for example, where I didn't really see it in the past was security. And now it turns out that it is, for the security space, it is one of the big things, that you want to collect a lot of data and then be able to figure out what is going on there. But there are also like many interesting things around humanitarian activity, like people trying to figure out who might be in danger of trying to commit suicide, because there might be signs, and you just collect a lot of data and then be able to find signs and signals. Like human trafficking, and there were lots of things, and we tried to showcase these as well. But they're also like on the technical side, I don't know. Years ago already, I've seen something that somebody had race cars on a track, and they were then measuring with Elasticsearch how far are they going and how far are they in which segment, and how can we optimize our race cars, which I found very interesting. Kibana didn't have a good visualization for it back then, so they had to build their own visualization. Probably we're getting better at that now as well. But that was something where I was like, oh, that's actually a fun and interesting use case, that if you collect a lot of data and then you need to visualize it or aggregate it, that totally makes sense.
Well, that was a key point that you just said there too. Kibana's visualization didn't cover their use case, so they had to build their own. You have to be able to, as an end user of a product or a project, if you hit the brick wall, racing brick wall, it's not always the project or the company behind the product that should do all the heavy lifting. because you've now hit a space that nobody's thought about using before. So to think that, oh, hey, we need this new thing, we need it by tomorrow, thanks. That was never on the radar before. So it may not be a simple solution.
That's definitely true. We try to have one or two like escape hatches in Kibana now, like there are Vega visualizations, it's basically you write some JSON and it visualizes something, and it's a generic open source library that you can use. It's maybe not the most user-friendly or easiest approach to do that, but we try to have more and more things where you can build something that you really need yourself. But it's true, we will never be able to support the specific requirements for every single domain. So if you have logistics and you want to have some specific logistics visualizations in Kibana, maybe somewhere down the road, but probably not. That's not something we will have tomorrow, because it's one industry of many, and we won't be able to support something for every single industry. Also, from the engineering perspective, I'm sometimes getting a bit careful or cautious. It's how many million lines of JavaScript will you need to write to make all of this happen, and how maintainable will it be in the long run? Because it's getting a lot of code. Sometimes you look at some pull requests and it's tens or hundreds of thousands of lines of JavaScript for big features. And I'm wow, how can you ever review that? Or how do we make sure that will be a healthy project in the long term? The colleagues seem to work a lot on that, and it works. But I'm just sometimes cautious, okay, you can build so much stuff, but should you build everything that is possible? Because the complexity will also kind of bleed through at some point. Maybe that's coming back to Kubernetes then again.
Oh, yeah. But to me, that's interesting because, we are facing the same problem. I don't know whether you are. I know quite a few other projects. It's kind of the more successful you become, the bigger the surface of the features that people want to use it for. And then you keep extending and generalizing until, and I'm not saying that's your case, until it kind of becomes too generic, right? And maybe not that useful anymore. Maybe not that good anymore at the specific things that people loved initially. I'm not now talking about you, just kind of, I feel that that's what's happening, at least in our case.
I think that's a general problem, right? That you see so many customers and you want to be a good solution for all of them, and then you keep adding features and you generalize, and then it's getting more and more complex, and kind of your tower gets higher and higher and higher, and at some point it basically topples over because nobody can manage it anymore. And I also don't want to say that we are doing this, and I don't think we are, but it's something that you need to be kind of careful and manage in the long run, that it's maybe at some point more is not always better. Yes, you can have 1,000 new features, but nobody will be able to know and manage them anymore anyway. Even for us inside the company, it's getting very hard to know. Everything is impossible, but just to know the majority of the features and things, it's getting very hard because just a lot of surface you have to cover.
Basically said another way, it's okay to say no as an engineering group.
As an engineering group, I think sometimes it's a bit easier, but then you have a sales organization as well. And they're we have these big customers, and also we have these revenue targets, and our salary depends on that. And I don't think anybody is saying, oh, they force you into the wrong decisions, but it's just a force field, and you need to be kind of careful. What is the right balance? Where do you go? How do you even out getting the right deals and doing something that is nice for single deals, and what is good in the long-term vision for the product?
Right, and that's what I meant by no. Your no may be shut down by executive level, which is okay, but then now you can have the real conversation. Right? Your initial answer shouldn't always be no. It should be a thoughtful no.
Yes.
And then knowing that you're going to be negotiating after the fact.
Yes. You will probably always need to have that argument. It's whenever you say it depends, my rule is that you can only say it depends if you say on what does it depend on. And I guess it should be the same for a no. You should always have a good reason why you say no, not just out of principle or we don't want to.
Or unless you're old like me, and then you can just say no and people maybe forgive you or maybe not. I don't know. What else? What else can we... So there was one more thing. So race cars and Elasticsearch, that's always a good thing. The humanitarian, the suicide prevention. I'm gonna call it that. That wasn't your words, my words, or the suicide indicators. Let's say that's a very interesting story.
I hope I remember those correctly, because I sat in a few presentations and saw what people were doing there, and I think it's basically a lot of suicides, I think, have like the same indicators, and then it was also a tool to give. So it was an external company that built that, but they built it on top of our stack. And I think they basically tried to help, for example, teachers to figure out like these are common signals, and then these are the signals you need to be aware of and pick up, and this is okay, and this is like a problem. Or other use cases I think that we had were human trafficking, where people were kind of figuring out who was vulnerable to that, and then how people were trafficked, and like routes and everything. That these are interesting use cases, but we don't build those. Others build them, but we're happy to support them with our software then.
Right.
So what's next for data? I don't know if, and what I'm gonna say is from pure ignorance. Are you jumping now into machine learning, AI, and stuff like that?
So, I mean, we bought a company that is, we call it machine learning. The thing we initially had there was anomaly detection of time series, which basically was like, this metric is wrong. Like we learn over time, this is the expected value. Like maybe you have some regular pattern, like these are the number of visitors you have on your site on a weekday at 12 o'clock, and now it's totally off. We actually had a funny use case where we were using the data from our own website, and we could see the anomaly when Amazon S3 went down like 2 or 2.5 years ago in one of the big US regions. And unfortunately, we had a dependency on that in our documentation and website, I think. And then we could clearly see that there were far too few people on our website. And that was luckily, or you could see that in the data. So I think the automation is getting bigger and bigger, because we always jokingly say there are not enough interns in the world to stare at all the dashboards that you could build. And humans are also not very good at figuring out like this is what the curve should look like. That this is something that we could automate away. So yes, the anomaly detection and general machine learning approaches, also like this is part of this group. Like you could, for example, figure out your website visitors. These are regular visitors. This is a bot. This is a denial of service attack that you could group into different groups, and then your website automatically reacts to that in a different way, because the denial of service you might block, the bot you might want to throttle, whereas your regular users you want to give a good experience, for example. And there are many things that we're trying to build there and are working on, and some are already available and are working well. That is definitely one thing. I think the next thing for data is always, it has to be more and more and more data. For the logging and metrics use case, I think Kubernetes is helping us a lot, because where you were using SSH and tail in the past, thanks to Kubernetes, this is not a thing anymore. So this is a good driver for us, and we are happy to take that one on.
You say SSH and tail isn't a thing with Kubernetes, but I beg to differ.
Yeah.
I still see people doing it.
Yeah, but we see people doing a lot of weird stuff. We see people wanting to move mainframe to containers. That does not make it right.
Yeah.
No, I'm sure some people are doing that, but I think that the pain is getting bigger and bigger, and so it's kind of a forcing function to some other solutions in the long run.
You're right that people do tail still Kubernetes containers directly and stuff like that, but what I guess that plays very well for Elastic, I mean, and many other similar companies, is that that's not a default thing anymore. So kind of by default in Kubernetes you're shipping logs. That's kind of like default behavior, and then you need to go out of your way not to do it, right? While before Kubernetes, the default was I store logs in a file. You want to know what's in logs? You open the file, right? You need to fight the default behavior. If my interpretation of logging in your case, right?
Yeah, definitely. And I think Kubernetes and other technologies are kind of like pushing a bit more to get over that, like, oh, we've always done it like this is the right way to do it, that people actually come to the conclusion this is not working for us in the long run like this. Or for example, with Kubernetes, you might need a bit more enrichment, so you might want to have like metadata from Kubernetes, like you might want to know like what is the namespace here, or which pod is this running, or which node or whatever. Those are all things we try to have, and I think that the classical logline is also a bit dying out. You want to have more these richer events which have more information around them, and that's another thing. But there with the classical log file, you're kind of stuck. You will need something that enriches and adds the right information where possible to give you a broader overview.
I remember from a long time ago, I was writing logstash parsers for a big company, and that was a huge nightmare. Not because of logstash, just to clarify, but because kind of like there are 50,000 different formats of logging and stuff like that. Is that still a thing? Do people still use that, or just ship it to Elasticsearch in pretext and get over with it?
So generally, on the one hand side, I think we're trying to tackle this from the two sides. On the one hand side, we have like automated rules for a lot of common formats, like if you have MySQL, Postgres, Nginx, Apache, whatever, we just know what the default log looks like, and we could parse it automatically. On the other hand, we would generally, if you can, always log in a structured format, because it's kind of stupid in your, for example, whatever, Java, PHP, whatever application you have. Your application has everything in a structured format. Then you write it out to a log line just to run a regular expression to parse it back. And especially with stack traces and everything, nobody really wants to do that. Or I always jokingly say this is the Stockholm syndrome. Like you get so used to writing regular expressions and assume this is the right way that you just keep doing that. But if you would write that out to a structured format, you could just skip all of that, because if you write out a log in JSON directly, Elasticsearch is also storing JSON directly. So that's pretty easy then. You basically just tail the JSON into Elasticsearch and you're done. And you have all the structured information you need. But some people don't want to have it easy. Maybe it's job security, I don't know.
It's not, because then it's harder to tail the logs and see what's happening.
You mean for humans to see what is...
Yeah, exactly. This was cynical, me saying, I mean, kind of like, but I know that a lot of people still want to see the logs, kind of in the application, and then having a log entry in one line instead of 5 lines might make more sense. We just need to convince those people not to tail logs anymore. But
yeah, I think especially with short-lived containers and them being all over the place, that connecting to a server and tailing the file directly, I don't think it's getting easier.
It's not.
No. And that's probably a good place to stop, because we're a little long, but wow, Philip, that was a lot of great information. And we did we sort of went all over the place. We went through the history of Elastic and Elasticsearch, both. Now Elastic's big, right? You guys keep buying and or acquiring.
Yeah, I think we're at 2,000 people now, or close to.
Wow.
So 3.5 years ago when I joined, we were 300, 320, I don't know.
Yeah, it was like that. I remember when I met you, which wasn't maybe 3 years ago, it was a couple of hundred people. It's kind of like, so you're like a disease multiplying.
That's not a nice way of putting it.
I'm kidding.
No, it's okay.
I'm kidding. But no, it's a great thing. It's a great thing. Absolutely.
Cool. So let's see. We got that. Were there any other questions that we had? I think that was it.
I have a bunch of questions, but I don't think this should continue for hours.
No, because we could. And people probably won't listen that long. But that's okay. If you have any questions or comments about this episode, you can reach out to us on the Slack team, DevOps20. That's DevOps, the number 2 and the number 0. And I can't see squat today. Sign up for a free account and join the podcast channel. If you want to ask us a question, has anybody left us a question yet? No, they haven't, because I haven't checked it yet. You can leave us a voice message using Voxer. You can sign up for a free personal account and then add DevOps Paradox as a contact and leave us a message. If you're the first one to leave us a message at the time of this recording, we still haven't gotten one, you're going to get a free book from Viktor, right? Is that still good?
Okay. Absolutely, yes.
All right, that's fine. Yeah, normally we have cameras on, but I'm on really bad Wi-Fi today, so he can't see my what? Anyway, if you are listening via Apple Podcast, please consider leaving us a rating and review, and tell your friends to subscribe. I mean, by far, Apple Podcast is still our number one listener. Stitcher's close behind, but in the middle is Chrome. So I guess it's Apple Podcast, Chrome, and then Stitcher. And then Overcast, I think. Those four make up 50%, and then everybody else falls in the middle. But anyway, enough about data. I wonder if we could have done that with Kibana. Could we visualize that? Never mind.
First, you need to put it to Elastic.
Yeah, I know.
You said it yourself. You cannot use Kibana based on AdSense or whatever statistics you're using.
Look, don't tell me what I know. Sorry. There are links to the Slack workspace, the Voxer account, and how to leave a review down below. To our previous guests that we've had on the show, please forgive me because I never asked this question. Philip, how can people follow you?
Yes, so I think Twitter is probably the ideal channel. It is a bit complicated because it is my last name, which is Krenn, which is almost horseradish in German. And then you take my last name Krenn and you do a rod 13 on that. And then you get XERAA, and that's my Twitter handle. That's how to find me on the internet.
Okay, Darin, you need to put it in comments. Nobody will ever remember that.
We'll put it into the comments, but just to explain how I got to that. XERAA.
XEAA?
RAA.
RAA.
Yeah, and it's a rod 13 of my last name, and it should be pretty unique, so people will find me with that.
Okay, yeah, because it's not... it doesn't exist. Okay, so I typed it wrong. Okay, XERAA?
Yes.
Yeah, okay. Send it to me in our chat, because I ain't finding squat. All right, anyway, that's fine. Yeah, okay. So we'll have it down below so you don't do the same thing I just did. It's like, what did he say? Let's see, what else? If you're listening to this, it's getting close in the U.S. to Thanksgiving time. Canada just had their Thanksgiving. What do you guys have towards the end of November in the EU area? Halloween. Well, but that's already happened by the time this comes out.
No. Okay. By the time, yeah.
This is coming out on November 13th. So what do you have coming up in 2 weeks? You're probably at some... Are you at any conferences? Either of you at any conferences after November 13th? Look at your calendars.
KubeCon.
You're at KubeCon, and where's that this year?
San Diego.
San Diego. Okay, so you're going to be at KubeCon. When is that? I don't even know when it is.
Somewhere November.
Good grief. Come on, man. You're making me do everything today. You're not showing me any love today. It's the 18th through the 21st. So if you're listening to this and you don't already have your ticket for KubeCon, just go ahead and drive to San Diego. Oh man, it's San Diego Convention Center. It's too bad you can't do Comic-Con at the same time to do KubeCon. That would be a really weird mashup. But hey, not today. All right, so Viktor, I'm going to completely ignore you because you're not showing me any love today. Philip, do you have any final thoughts?
I think I'm pretty much done.
You're pretty much... See, you just did the same thing that Viktor does. You're the right person for this show. Thank you so much. For everybody still listening, thanks again for listening to this episode. What number is it? I've already lost track. 29. See?
Thanks a lot for having me.
Yeah, man, Philip, thanks for coming on. Like I said, check him out on Twitter. Are you going to be at KubeCon too or no?
No, I'm mostly sticking to Europe. Though I think I'm doing some nice trips at the end of the year. I think there is DevOps Days Tel Aviv in December, and I'm going to B-Side South Africa, and well, it will be summer there. So I'm also sticking to some of the nicer trips now, because the conference season will end at some point.
Let me just clarify your knowledge of geography. You start the sentence with saying in Europe, and continued with Tel Aviv and South Africa.
So for us, it's EMEA, and EMEA is basically Ireland, Nordics, Russia, Israel, South Africa. That's kind of like the greater region I generally try to stick to. A lot of Central Europe, but also a bit of places a bit on the side, especially when the temperature drops in Europe. Israel and South Africa are nice.
Fair enough. Thanks again for listening to episode number 29 of DevOps Paradox.